Okay, hey everybody, Maya here, and this is Mathelingual second week. And like I mentioned a little bit last week, now we're going to delve into some of the interesting parts of algebra, namely the algebraic expressions. So basically what we're going to be doing today is going through 4 examples of evaluating algebraic expressions. Now, when I say evaluate, I mean we're just substituting a number in for each variable in the expression. And then, once we do that substitution, then we'll just simplify the expression using the order of operations. So, quick recap, because this is really, really important when you're doing even the basic algebraic expressions. You need to remember this acronym. Pretty sure acronym, not acrostic, PEMDAS. So what that stands for is parentheses first. So if you've got any numbers, any quantities in parentheses, you simplify those first. Then you've got E, which is exponents. So if you've got any kind of numbers that are raised to a power, then you simplify those next. And then you've got multiplication, division, which really, I know it goes multiplication, division, but really you just go from left to right. So if you've got division on the left and then you get to multiplication, do division first. It just depends. This is a left to right type of thing. And the same goes for addition, subtraction. So addition, subtraction, that's also your left to right type. So parenthesis, exponent, multiplication, division, addition, subtraction. Pretty straightforward. And in any case, even if you had, say, a lot of jumbled stuff in parentheses, like let's say you've got an exponent, then you've got division, you're still going to apply the order of operations just within that parentheses that you happen to be simplifying first because of PEMDAS. Okay, so let's get rid of this. I just wanted to go over that because that is a really important concept when you're working with algebraic expressions, because if you simplify in another order, in other words, if you don't use PEMDAS, then you're going to end up with a totally different answer. So that's really important. Okay, so example 1, got my notes here. Oh, real quick little notebook hack, I guess you'd call it. Bookmarks. If you have some kind of close tags or tags from items you buy and the tags are actually not that bad looking, keep them because they might actually be a good bookmark. Anyway, getting back on track. This is the first example. So we've got 7 times the quantity A plus 4 plus 3B minus A. So that looks like a bit, but let's say we know that A equals -4 and B equals 5. Okay, so we are given the values for these variables. We can just plug them in. So we get 7 times -4 plus 4 plus 3 times B, B is 5, minus 8. Okay, order of operations. I'm going to simplify this part first. -4 plus 4 is just 0, right? We're just adding a number to its opposite. So you've got 7 times 0 plus 3 times 5 minus 8. Then we're going to do multiplication. So these two guys. So 7 times 0 is, of course, 0. 3 times 5 is 15. And then you've got the minus 8. So that 0 goes away because that's nothing. So really we've got 15 minus 8, which is 7. So that is your answer, 7. When A equals -4, B equals 5, your answer is 7. Okay, so now let's try a little bit more, I won't say more complicated, but it might look a little stranger, especially if fractions kind of make you cringe a little inside. I know, sometimes they make me cringe inside a little bit. I think mainly because they're so different from integers in some ways, but then again, maybe not, because you can still write integers as a quotient of integers. You can still write integers like fractions, right, with 1 on the denominator. Anyway, this is our next example. X over 2 plus y squared for x equals 1 and y equals 1/2. Now pay attention here. This is going to be really important to get. Okay, we're going to plug these in. 1/2 plus 1/2 squared. So this is an exponent, so we're going to simplify this first now. Whenever you have a fraction raised to a power, you're going to raise both the numerator and the denominator to that power. So what that means is we're going to have 1 squared over 2 squared, okay? So that simplifies to 1/2 plus 1/4. Now we just got to add these two fractions. Maybe you're thinking, how in the world do you add fractions with different denominators again? Well, don't worry. It's really simple. You just find the LCD. LCD means least common denominator. So in this case, what do 2 and 4 share, like when you keep multiplying them, okay? So 2, if you go from one group of 2 to two groups of 2, two groups of 2 is 4, so their LCD is 4. So how do you change 1/2 into something with a denominator of 4? What you got to do is 1/2 times something over something equals something with 4 in the denominator, right? So you multiply 2 by 2 to get 4. So you're going to multiply 1 by 2, and that gives you 2/4. So that is your equivalent form of the fraction with a denominator of 4. So what that gives you then is 2/4 plus 1/4, and that's easy. You just add the numerators. Do not add the denominators. We just fixed that issue. That's 3/4. Okay, so your answer for this problem, therefore, is 3/4. Okay? So that gave us a little chance to go over the fractions, which is also an equally important point, especially when you're dealing with algebra. You don't want to be held back by something like trying to combine fractions that have different denominators. It's a very crucial part of the step. Okay, next example. It's going to be a little bit more challenging, so check it out. 2 times the quantity x squared minus y squared all over 3. Yeah, that kind of looks like a little bit of a monster, doesn't it? But x equals 6 and y equals -3. Super easy to just put in. So 2 times 6 squared minus -3 squared all over 3. So we're going to simplify the parentheses, and therefore the exponents within them, the powers. 2 times 6 squared is 36. -3 squared is +9. Do not write -9, because a negative multiplied by a negative cancels out and gives you a positive. So -3 squared is 9, and then we've got the over 3 part. And this is 2 times 27 over 3. Now there's two ways you could simplify this fraction. You could go ahead and multiply out the numerator to get 54 over 3, which is 18. Or you could do a little bit of canceling out of common factors. So if you divide 27 by 3, you get 9. And if you divide 3 by 3, you get 1. So then you just have 2 times 9 over 1, which still gives you 18. Now, one thing I want to make very clear. This would not be the answer you get if these parentheses weren't here. If these parentheses were not here, you would have 2x squared. Like, let's just say we're getting rid of those parentheses. You'd have 2x squared minus y squared over 3. And let me show you real quick, what would that do? Well, using the same x equals 6, y equals -3 code, that would give you 2 times 6 squared minus -3 squared over 3. It sounds about the same, but really it's not, because you get 2 times 36 minus 9, right? And then you have over 3. But then you end up just multiplying the 2 by the 36. You don't multiply 9 by 2 like we did before. So you have 72 you would have 72 minus 9 over 3, and that is 63 over 3, which is 31. So see, very different. This is not equal. Very different. Okay, so keep in mind, the parentheses are more important than you think. And especially if you're, say, plugging a calculation into a calculator, you have to be really careful with parentheses, because if you don't have enough parentheses, sometimes the calculator will misread what you're trying to figure out and then give you a totally different answer, as we just found in this slightly similar example. All right, so now for our last example for this video, I'm going to bring in a little bit of a word problem. It's nothing too bad, but it does involve American football, which I know close to nothing about. So I'm just going to jot down the key parts. Okay, is this thing still going? Just got to make sure. Okay, we're rolling. That's good. That's good. Just got to make sure, because technology can malfunction too, right? Okay, so example 4, a word problem. A word problem. Okay, so it regards American football, and okay, these are the parts I gotta remember myself, because I would not remember them otherwise. So let's think about American football, the different kinds of goals or scores, I guess you can get. A touchdown is 6 points. An extra point kick is 1 point, and a field goal is 3 points. Now, for those of you who know a little bit more about this sport than I do, kudos to you, because I do not. This is just part of the math problem I'm working through. So I'm just going to shorten it, because those are the abbreviations I found in my book, Algebra 2. Touchdown is TD, extra point kick is EPK, and field goal is FG. So let's say, knowing that these each are equal to different amounts of points, let's say a team scores 3 touchdowns, 2 extra point kicks, and 4 field goals. So how many points do they have total? So we want to find the total points, okay? So we can create an algebraic expression to model this problem. So what I'm going to do, so let's say, I'm just going to use this little box here. I think that should be enough. Okay, so let's say, okay, we've got 6 times t, okay? T is the number of touchdowns, right? So for every touchdown, you're going to get 6 points, right? That's why we multiply it. So like 2